Hello and welcome to SAT Prep video number 9. It is on data analysis and statistics. It's the second part of these concepts. So a little refresher from some of your previous math classes about terminology. What is the mean? Okay, the mean is the word average. It's probably what it's more commonly known as. And to calculate the average, we add up all data values, and then you divide by the number of total data values. Okay, so that's how we calculate average. The median is the middle. Okay, so in this case, to find the middle, you want to line up all data values in order, and then you pick the middle. Okay, that's called the median. Now, if there are two data values in the middle, so a little side note, if 2 in the middle, this is when you have like an even number of data points. So if I had 10 data points, there would be 2 numbers in the middle. Then in order to do this, I would have to find the average of those 2. Okay, the mode means most. So mode is the most common data value. And there could be no mode, so there could be no mode. There could be one mode, like one modal value, or there could be multiple modes. So there could be definitely more than one mode for any given scenario. And the range is the biggest number minus the smallest number. Okay, so that's some terminology for statistics, some basic stuff. Looking at this information, we have obviously a lot going on here. We have a car dealership in Moline. We know that there are 70 people in this survey, very important. Okay, and 42 chose to participate. So this graph over here is the 42 people who chose to participate in the survey. Okay, you'll notice that this is 10, this is 15, this is 14, and this is going to be 3. Okay, so 10 plus 15 plus 14 plus 3, that gives you your 42 data points. What is the mean number of cars per household? Well, there are 10 households that have 0 cars, and there are 15 households that have 1 car. There are 14 households that have 2 cars, and there are 3 households that have 3 cars. Now, this would be the same as adding 10 or adding 0 10 times, or adding 1 15 times, or adding 2 14 times, or adding 3 3 times, but we should use multiplication to help us speed this up. And then how many total people were surveyed were actually part of the survey results. That would be the 42 that we had, not the 70, it's the 42. Okay, so that would be your mean, and that would be approximately 1.238 cars. What is the modal number of cars? Well, mode means most, right? Mode means most. So that would be 1 car per household. Now, you wouldn't say 15. 15 is the number of times that occurs. So the actual data point is 1 car per household. What is the median number of cars per household? Well, there are 42. So there's 42 total, and half of that is 21. Okay, so 42 is an even number, and that means that we're going to have 2 numbers in the middle. So number 21 and number 22 are the middle, quote unquote middle. Okay, that's our median. So if we look, those both fall in this range, because if I have 10 here and 15 here, that's 25 total. So 21 and 22, those data points fall actually in this bar right here of 1 car. So we would just say 1 car. Number 4, if you select one respondent at random, what is the probability that the respondent have exactly 3 cars? Well, there are 3 people that have 3 cars, this number up here, and there were 42 total people surveyed, okay, that actually responded to the survey. So that's our probability. Okay, so this is the number with 3 cars, and this is the total number of respondents. So that gives us 1 over 14, which is the same as 0.07, or you could say 7%. Usually for probability, we just leave it as a decimal. You don't have to turn it into a percent necessarily. Number 5, suppose all respondents later attend a focus group together. If you select one respondent at random, what is the probability they have less than 2 cars? So less than 2 cars, let's talk about that. That would be 0 or 1. Okay, well, how many people had 0 or 1? That was 10 plus 15. So that's going to be 10 plus 15 divided by, again, total number of outcomes, which is 42. Okay, so 0 cars is 10, and so this is 10 people. And this is 15 people that had 1 car. Okay, so that gives us 25 over 42, or we can do a decimal, 0.595. Number 6, the consultant assumes that the survey results are representative for the entire town. If there are 18,573 households in Moline, how many households would the consultant predict to have exactly 1 car? So let's first of all start with how many have 1 car, right? So 1 car is 15 out of 42. Now this is from the survey, okay? So this is from our survey. We want to know, what about the whole population? Well, that would be X number of people out of 18,573. This is the entire population. Okay, so we can use a proportion to help us solve this, and we cross multiply. Okay, so in this scenario, you would multiply 42 over and 1857 over to the other side, and you then would divide by 42. So you would get X equals 6,633.21, which is, you got to kind of round that. You can't have a decimal of a household, so 6,633 houses. Okay, so we have to use proportion there because we're assuming that these survey results are going to carry over. Number 7, one could argue that the consultant made a questionable decision when assuming the results of this survey are representative of the whole town. I mean, think about the results here, right? There's 18,000 people in this town, and we only got 42 people to respond. So our sample size is not big enough. So sample size, which is the 42, is not large enough. Okay. Also, why did 28 people, that would be 28 people, remember there were 70 total that were sent out, not respond? So maybe they are, afraid to respond. They just didn't care about responding. They were embarrassed because they don't have any cars at all or something like that. There's a lot of possibilities. So you can't make this assumption. At least I would say you probably can't, that this data holds for the entire town, because 42 people out of 18,000 people, that's a very small population. You probably need a much larger sample size. Okay, here's some practice problems for us. A survey was taken of the number of pets in each household in this county in Wisconsin. The mean number of pets, so the average, so our average or the mean, the same thing, is 2.57. The median, which is the middle, okay, remember the middle, is 1. Which of the following situations could explain the difference between the mean and the median? Well, let's think about these numbers. Remember, the median is the middle. So if I lined up all the responses for this survey, the middle number would be 1 pet per household. But then how come the average is 2.57? In order for the average to be that much higher, you'd have to have a few people, probably several people, that have a lot of pets. Like if some people, and this is Wisconsin, so maybe they're on farms and they have many pets, right? Or even places in Illinois, this happens too. So let's say some families have like 10 pets or 15 pets or 20 pets. And then all those ones that only had 1 pet, that average gets dragged up a lot higher because of the people that had those extreme numbers of pets, okay? So if there are a few households that have many more pets than the rest, then that can cause the median to be dragged up. So this pushes the mean, that is, the mean higher, okay? So in this case, the median actually gives you a better idea of what's going on, because those large number of pets for certain people, it's kind of skewing the data. 2 and 3 here. According to the information table above, what is the approximate population of California in 2011, 2013? Okay, so in this scenario, we know that California has 235 jobs per 10,000. So if I do 235 per 10,000, okay, and then we want to know the actual population. You see how it says total number of jobs? Well, the total would go up top. And that would be my X down there, okay? And again, if you cross multiply, you're going to get your answer of X equals 3.8. If you use your calculator, you're going to probably get scientific notation times 10 to the 7th, which is 38,490,000. So that would be 38.5 million. Okay. So you had to use that table and just use the column with the California in it because it says specifically California, right? And we know we have this kind of ratio we can set up where in California, there's 235 jobs per every 10,000 residents. So that's my 235 over 10,000. And then we know in California, there's a total of 904,500 jobs added in the state over X population. My X is my total population, okay? So your population in California is this X variable down here. Cross multiply and divide and you've got your answer. Okay, number 3 says, according to the information given in the table above, which of the following conclusions can be drawn about per capita job growth in the first 5 states? Okay, in the top 5 states, I should say. So if we go through these, let's just go through them in order, right? Job growth was greatest in North Dakota because it had the greatest number of jobs per 10,000 people. So if you look, and this is how you can compare growth in various states because some states are very populated and others are not. So you can't just say like, what's the number of jobs that were added? That doesn't give you a good idea. If you look at it and you compare it to per 10,000 residents, now you can compare across different states. Well, look at all these numbers. Look at North Dakota. North Dakota added way more jobs, actually more than triple the next highest number of jobs per 10,000 people. So North Dakota had actually the best overall outcome, right? Because they're adding the greatest number of jobs per 10,000, so they had the greatest growth. So the first choice there was our best option, actually. That was very obvious from the information there. This number is so much larger than the other ones, so we definitely had the greatest growth. And we're comparing per 10,000 people, so it's a direct comparison. Okay, last set of questions. We're going to use this table, or this graph that is. We have, 50 franchise locations. That might be useful in the information here. And then we have, this tells us the gross revenue of our stores in in thousands of dollars, that is. Okay. And you'll see there's a line of best fit. This line right here is called a line of best fit. And that line tries to predict the data. So this predicts the data. And the data are all those points. So we're drawing a line that kind of goes in the middle of all the points, essentially. Number 4 says, which of the following best describes the association between the number of employees at a franchise location and the gross revenue at that location? Well, look at your axes. This is the number of employees. This is your gross revenue. So basically, what is that line? Is that going to be a strong positive or a weak positive? You see how it has a positive slope? Okay. So that means we're going to have some kind of positive correlation. And the points, the data points, are pretty close to the line. So data points pretty close to our line. So because those data points are really kind of close to that line, we would say this is a strong positive association. If those data points still showed a positive slope, but they were more spread out, then we would say it is a weak positive association. Last one, number 5, to the nearest employee, what does the line of best fit predict will be the number of employees at a store with a gross monthly revenue of $100,000? So gross monthly revenue of $100,000 is going to be right here. Because remember, this is measured in thousands of dollars. So this is 100,000. Okay, so take that value, carry it over to your line, and what does it come down to here? This comes down to, it looks like 12. Okay, and that's the number of employees. So we put in our table here, and our grid in 1, 2. So then you bubble in 1, 2. Okay, and that's going to be it for this video. Thank you guys for watching. Remember, if you ever have any questions or want some extra help, please come on by our support for SAT during 4A, 1B, 2B, and 3B. Have a great day, everybody.